So one of the questions you can expect on your tests for exam 3 would be to find complex roots of a complex number. Now, you could also write this as 0 minus 16i. So that's another version of that. We're going to need that to help find the fourth roots of this. There's a couple formulas that you could use. One that we've gone over in class, which is this one. That's in radians. But it occurs to me we haven't practiced one in degrees. Degrees is probably a little bit more user-friendly, so let's practice one in degrees first. Let's see. So here's your problem, or here's your complex number, and the first thing to do is to write that in polar form. So I've got that plotted down here. You got a real and imaginary axis. So that point is right straight down on that imaginary axis at a point of 0 and negative 16. There's two things we need to know in order to write it in polar form. That is r cosine of theta plus I times the sine of theta. We need to know what r is, and we need to know what theta is. So both of these are pretty easy if you graph it. And I encourage you to graph anything that lands on one of these axes to try and determine r and theta. I wouldn't necessarily use a bunch of trig formulas. You're going to get r equals this distance, but that distance is just what?
Out there.
How far is it from the origin down to here?
If you go,
It'd be just 16. 16 is the distance. We're not worried about the negative sign there. And how about this angle in degrees, starting out at the positive x-axis, going around with the negative imaginary x-axis? 270. So there you go. Theta is 270. R is 16. So this number can be written as 16 cosine of 270 plus I times the sine of 270. And then we're going to plug it into our formula here, which is going to be this one right here. Let's take stock of a couple things here. First of all, n comes from this part right here. N equals 4. Looking for the fourth roots of this problem. So that's going to be z sub k is the fourth roots of r. R is 16 in that one. 16 times cosine of theta. Theta was 270 plus 360 times k over 4. And then you're going to have plus I times the sine of that for the same angle. So I times the sine of 270 plus 360k over 4. And that's for k equals 0, 1, 2, all the way up to n minus 1. So it's going to be 0, 1, 2, and 3 for us in this particular problem. Now before I start writing down the individual values, it's worth it just a moment to simplify this as much as possible. 4 through that works out to be 2. This is going to be cosine 4 divided by, or 4 divided into 270 is going to go 67.5 times. 360 divided by 4 is going to go 90 times, so plus 90k. And then the second part, you don't have to think about. This angle and this angle are going to be the same. It's just going to be I sine of 67.5 plus 90k. So that's our z sub k in general. Now what I'll ask you to do is to fill this out for, say, z sub 0. If k is 0, then it's going to be 2 times the cosine of 67.5 plus I times the sine of 67.5. Okay. How about z sub 1? Well, it's still going to be a 2 cosine 67.5 plus 90 times 1. So it's going to be 157.5 plus I times the sine of 157.5. And then z sub 2 will be 2 times cosine, well, if I put in a 2 there, that's 180 plus 67.5 is going to be 247.5. So 247.5. You seeing where that's coming from? Okay. And then I times the sine of 247.5. And then the last one, z sub 3, is 2 times cosine. 3 times that is going to be 270 plus 67.5 is going to be 337.5 plus I times the sine of 337.5. Now you could be asked, and you should be ready, to convert any of these to numbers in rectangular coordinates. So let's just pick one at random. Just give me 0, 1, 2, or 3. 2. All right, let's take this one and turn it into rectangular coordinates. Now, on my calculator, I've got my calculator in degree mode. So let's do that. I'm going to put 2 parentheses and then cosine of 247.5. 247.5 plus I times the sine of 247.5. Now I, you can find by hitting the second key, then the decimal. That gives you your I, sine of 247.5. Close parenthesis for the sine, close parenthesis for this complex number, so that it gets multiplied by 2. And do yourself a favor, hit the store key and store that in X. That's going to give us a way to check our answer. Now, if you're asked for a problem like this to write it in the form of A plus BI, there it is. Chances are I'd ask you to round to the nearest 10,000th place, which would be negative 0.7654 minus 1.8478 times I. But the reason I did this here was so that I could show you how to check it, make sure you got it right. These are supposed to be the 4th roots of this number. So I should be able to take this number, and I've got it stored in X, and raise it to the 4th power. What should I get if I raise this to the 4th power? Well, should get what I started with, right? I started by taking the 4th roots of negative 16i. If I raise this to the 4th power, I should get negative 16i. Let's see that that works. And bam, perfect. That should work for any and all of your answers right here. You should be able to give me A plus BI, or if asked to, do it in exponential form. Thing about exponential form is these angles have to be in radians to begin with. Exponential form does not work going from degrees to exponential form. It only works from radian to exponential form. Good? Sweet.